Happy New Year, everyone. Welcome to 2023. I hope you're only mildly hungover, and it's a new year, and that means new projects, or whatever you call this mess. If you're a member of my Patreon, you already know what's going down. This is something I've been kind of tinkering with a little bit. I wanted to hold off on a video until I kind of had a vague idea of what's going on here so I can walk you through this while still sounding at least a little bit like I know what I'm talking about. I mean, I don't, but I can at least try to sound like it. So let's take a look. So this absolute horror show here is a brushless DC electric motor and a power supply, and here you can see what actually powered this whole project. But this is actually what I'm doing with the extra lithium ion cell out of the 2020 Honda Insight battery pack that I bought, and used 3 of the 4 sub packs for my Honda Insight lithium swap. So with the extra one, I really didn't know anything about the specs. I just wanted to use it for something. So I bought this Dali BMS off of eBay. BMS is a battery management system. As near as I can tell, it serves two purposes. The basic function of a BMS is to balance the battery, and what that means is there's a whole bunch of lithium cells in there. There's 12. That makes us a 12S battery, and they're lithium ions, so you can kind of get your voltage from there because lithium cells are like 3.2-ish volts per. Anyway, balance leads are a wire coming from a terminal on every single cell in here, and those go in here, and it allows the cells to charge or discharge each other to maintain a balance within a few millivolts. The way that this is wired up, I didn't understand how to wire any of this up, and we're dealing with, this Honda connector here. So what I did was I took off these plastic covers, and saw which wires were going where. And what you do is you start with the black wire, and that goes on the balance lead closest to the negative terminal of the battery, and then you work your way from there, and eventually you'll get them all wired up. And before you plug it into the BMS, you want to take your digital voltmeter and probe every single adjacent pin. So the first 2 pins, pin 2 and 3, 3 and 4, 4, 5, 5, 6, and those should all only show 3.2 volts differential. If that's all good to go, then you can plug it into your BMS, and the BMS actually saps a little bit of power off of here to power itself. Now this is a smart BMS, so it has this little Bluetooth module, lets me set a whole bunch of things. This says it's for LiFePO 4. Well, guess what? I can get in here and tell it that these are lithium ion cells, here's their specs, and all that fun stuff through an app, which is actually broken right now. The app updated, and now I can't control my BMS. So it's a good thing I got my settings set before it did that. There's also a temperature probe here. I doubt this is an ideal way to have the temperature probe, but, there it is. The other thing that this does is it has over and under voltage protection, because it sits between your load and the negative terminal of the battery. So this is no longer the negative terminal of your battery. This is P-. And I'm assuming it just has a big ol' FET or relay in there, so that if it detects too much current draw, or the battery is getting overcharged or over discharged, it can cut the battery off from whatever it is that is supplying that voltage or sapping that amperage. Right here we have a generic 3.2 amp battery charger. Just normal thing, very slow, but it was also cheap. And then we have a terminal block, and this terminal block gives us our positive and our negative, and goes to this motor controller right here. This is the finest off of Amazon. It is a brushless DC motor controller, 48 volts, 34 amps, claims to be 2,000 watts. I doubt that very much, but that's what it claims. And then I have this throttle that I also got off of Amazon, because, like an idiot, I forgot to get the one of these that actually came with a throttle. We have a whole bunch of plugs here. They're all just the standard Honda style thing, so I was able to crimp on the appropriate connectors for the key and the throttle 3-pin potentiometer. This thing also has, you can set 3 different speeds, and you can do regenerative braking with these purple wires. What else? You can reverse it with this wire. Some other stuff I'm not going to use, but anyway, so what we have here is a self-contained zip tie amalgamation that is effectively an e-bike battery, a very bad one. This is only 5 amp hours because well, hybrid batteries need to have extremely high charge and discharge rates. I think this can charge at 10C, which is pretty insane as far as lithium goes, especially hobbyist lithium. But that and that's so that you can get really strong regen braking in a car. In this case, a 2020 Honda Insight. This is also used in the NSX and pretty much everything else Honda made with a hybrid powertrain. But with that, the downside of that is the energy density is absolute garbo. So this is only 5 amp hours, which as I understand it, is pretty poor. So I don't know how good this is actually going to be. I'm just kind of doing this to dip my toe into this whole world. I think this kit was like $160. This was like $100. This I already had, and this was like $20. And if I turn the key, oh, is the key already on? The key was already on. It works quite well, actually. So, you can probably tell where this is going already. This was the cheapest functional vehicle I could find on Amazon at the time. I bought it with a whole bunch of Amazon gift card points that I had saved up. It is a mini bike with a 50cc 4-stroke engine. This is, I believe, just under a horsepower. It's pretty lethargic, and pretty loud. I don't really like it. So it also has the same metric, what is that called? That's a chain. Yes, it has the same metric chain that you find on those sorts of kits. I think you see where this is going. So yeah, I'm building an electric pocket bike. 2,000 kilowatts in theory, which is 2.8 horsepower, so more than double the stock gas engine, and instead of making that power right at the tippy top of the rev range, it'll make that power from the word go. I fully expect to be hospitalized after this. I am already in severe pain from my accident in the Insight. That has not been fun, and it is cold in here, but hey, let's build a mini bike. Why not? So step 1, I think, is going to be to get this weed whacker engine out of here, and that could not be simpler. There are some hilariously undersized fasteners, looks like 4 of them, so it's basically a Volkswagen Beetle. So I'm going to yank this guy out of here, and I don't know, throw it in the trash. I'm really not sure what we're going to do with that guy. One moment. This is objectively terrible, but also kind of brilliant at the same time. This might be the worst EV build on all of YouTube, but also almost elegant in its shittiness. Let's see, where's the mounting hardware? It's under the tire. Okay, I can work with that. No. Unfortunate. I will have to dig in my bolt bucket, but I'm thinking that I bolt the back through this bar here, and then, I don't know, just kind of tension it using the front. Or I sort of do this number. Maybe I just do that and just freaking bolt the front of it through this plate. I think I might go that route. I can't really tension it per se, but I'm here for a good time, not for a long time. This is the sloppiest thing I've ever seen in my life. Shockingly, the battery is actually quite sturdily in there. And cable management could use some work. What the heck am I doing? My engineering teachers in high school absolutely hated me for eyeballing stuff like this, but the thing is, most of the time, it would work. Which made them even more upset. I should probably get some cutting oil. This is definitely cutting oil. I am measuring. Look, I've got my, getting my hole centers, so I know where the other hole goes. It's there-ish. You know, my family's actually from Germany. You know, very fastidious people, known for, you know, great works of modern engineering like the Audi 3.0. No, wait, not that. Okay, well, this is all genuinely awful, but does it work? Keys on. There we go. No. Oh gosh, it does. It just moved. It does work, and what an amazing mount. Okay, so I've been doing some testing. It does go forward, but I was like, why do I not have any throttle control? And why is it so slow? Well, I wired up the old kill switch to the reverse switch, and then forgot about it. And it turns out this is in reverse. When I put it in forward, the wheel spins backwards, but holy crap. So I need to go read the Amazon reviews that mention how to reverse the spin of the motor, because this is a three-phase motor. So there are 3 big old wires coming from it that carry the main current, and then there's all of these Hall effect sensors. And I have to switch the 2 of these wires, and I think 3 of... Well, fortunately for me, the instructions actually tell me exactly how to do this, and it's really simple. You just pop open our terminal block here and swap the blue and green wires, and then here you swap the yellow and blue. Yeah, so the yellow and blue, these 2 wires, you swap them. And I swapped them on the motor side. I don't know. I did it on the motor side. I don't really quite know what my reasoning was, so we'll just go ahead and pop the cover back on over the scary bits here. Here we go. And now it should spin in the correct direction. And I did mount the motor a little better by putting some zip ties on the back here, so now it's not flopping around. I added more zip ties to the battery mount and then retained them with some nuts. I need to cut all my danglies here, and then I need to retension the chain. It has gotten, oh gosh, it's gotten just a bit loose. Just, you know, just a little. Gosh, I hope there's enough adjustment. There should be. Pretty straightforward. Loosen and then tighten. And then the wheel is tensioned. So I'm going to do all of the things that I just mentioned. Does burn mounts. Oh, also added a snazzy headlight. Thank you, Davin. Well, I'm gonna go get a helmet, because I'm kind of scared of this right now. Also, I put some air in the rear tire for extra spinal compression over bumps. So I went and had a look at the video I made when I first got this thing. It looks like it topped out at 17 miles an hour. And what I just did was 22. Uphill, kind of. And it got there pretty much instantly, as opposed to before where it would take the entire length of the street. Unfortunately, my state of charge went down to like 55% after, I think I just went like a mile, maybe mile and a half. Probably not a mile and a half, probably just a mile, and I'm down to 50% state of charge. So range is non-existent, more or less. This is not going to take me far, but it is a fun toy. 5 amp hour battery is just frankly pathetic. I need to get something better, an actual e-bike oriented battery. I mean, let's just take a look here. Let's take a look at what there is for 48 volt e-bike battery, 100 amp hour. I'm calling BS on that. A 15 amp hour, $300. Here's a 48 volt 14 amp hour with charger for $219. So that's a bit closer. Something like that would be ideal for a project like this. So hey, $219 on Amazon. I might look into getting that. See if I can make this thing actually usable as transportation, and leave some ideas in the comments what I should do with this 4-stroke little Honda knockoff. I genuinely have no ideas. Well, there we go. That was pretty much a day's work, and I went from a pile of stuff from Amazon to a functional electric motorcycle. And I'm astonished that it worked. Thanks for watching, and I hope your 2023 is off to as good a start as mine is. I'm gonna go ride some more.